Let's turn our attention now to the idea of related rates of change. We understand what it means to talk about a rate of change, but I want to talk about the idea of how one rate of change relates to another. There are two primary learning objectives that we want to work through. The first one is we want to be able to actually find a related rate of change, and then we want to be able to use these rates of change to actually solve real problems. So let's take a real quick overview of what this thing's about. In the real world, the rate of change of one object changes is often related to the rate that another object is changing. So think about the area of a circle. If I have some circle here, I can calculate this area as equal to pi r squared, where r is the value of the radius. Now, the area of the radius is going to be changing if the radius changes. So think of this radius being extended out a little bit. Now I have a circle that looks like this. So if this radius is actually a function, perhaps we're talking the radius as being a function of t. It's changing as time changes. It could be going in and out. Who knows what it's doing? As time changes, the radius changes, the area changes. So the rate of change in the radius will have an effect on the rate of change in the area. So if I think of the radius as a function of t, I can write the area as actually now being a function of t, and that's going to look like pi times whatever r of t is squared. From here, I can think about taking derivatives, probably or possibly, depending on the scenario, an implicit derivative. And we can actually start thinking about the rates of change of area, which is the first derivative, as a function of the rate of the change in the radius in this particular example. So in a nutshell, that's basically the idea of what these next several videos will be looking at. So let's take a look at some actual examples and see how this is applied.